Hello, ladies and gentlemen. Today we are going to take a look at writing some geometry proofs. So we've been looking at algebraic proofs and justifying our reasoning, and now we're going to take a look at how this applies to the geometry that we already know, understanding proof writing, and of course, justifying our reasoning. So for this, you're going to need that reference sheet for your proofs, so make sure you have your proof portfolio there handy so that you can use that for the properties as well as some of the common definitions or postulates that are used. So here's proof number one. We need to start by having you write down that given information up there. So please make sure that you are writing that given, and then also write there what you are trying to prove. So you need to make sure that you're writing the given information as well as what you're trying to prove. I also have a little picture up here in the corner that's kind of handy, but you don't necessarily have to have a picture in order to write this proof, but it sure does help. So the first thing we are given is that angle 1 and angle 2 are supplementary. And if you look at that picture up here, it shows angle 1 and angle 2, and they look like they are supplementary. That is that they would add together to make 180 degrees, right? And then angle 2 and angle 3 are also supplementary to each other. So that means that they also add to make 180 degrees. And we are trying to prove that angle 1 is the exact same or congruent to angle 3. So we're going to go through here, writing in our statements and then justifying our reasons just like we have done before. And let's go ahead and get started. So every proof that we write, guys, will always begin with that given. So angle 1 and angle 2 are supplementary, and the reason we would say that is because that was given to us. And then our second statement would be that angle 2 and angle 3 are supplementary, and again, because that was given to us. So after we've written our given, then we want to work with the given information here to see how far this can get us. So if we know that angle 1 and angle 2 are supplementary, you should be thinking in your head about that fact we said about the 180 degrees. You know that angle 1 and angle 2 need to add together to make 180 degrees. You know that. So that would be the next step in our proof. We are going to say that the measure of angle 1 plus the measure of angle 2, that means we're talking about their degrees, adds together to equal 180 degrees. And how did we know that? We knew that because of that keyword supplementary. Because we understand what that word means, we know that those two angles add together to make 180 degrees. So the justification we have there is that definition of supplementary. So we saw the word supplementary and we knew what that meant. And we would do the same thing with angle 2 and angle 3. We saw the word supplementary there, so we also know that angle 2 plus angle 3 there, the measure of angle 2 plus the measure of angle 3 equals 180 degrees as well. For the same reason, definition of supplementary. Now when we look at those two steps that we just wrote, see how they're both equal to 180 degrees? So 1 and 2 make 180, 2 and 3 make 180. So by the substitution idea, we can go ahead and make this one equation. That measure of angle 1 plus the measure of angle 2 has to be the same as the measure of angle 2 plus the measure of angle 3, since they were both 180, right? And that property that allows us to do that is that substitution property. Basically, we substituted the expression angle 2 plus angle 3 in where this 180 degrees would be. All right, now that we are here in this next step, as I'm looking at this equation, I see that we have angle 2 on both sides of the equal sign. And remember, our goal is to try to get to a place where we have only 1 and 3 left. So I would use the subtraction property to subtract measure of angle 2 from both sides, leaving me with the measure of angle 1 equals the measure of angle 2. And again, that was the subtraction property of equality because I am basically subtracting the measure of angle 2 from both sides. And that's close to what we want, but we want angle 1 congruent to angle 3, not the measure of angle 1 equals measure of angle 3. And I know you're probably thinking, isn't that the same thing? Kind of, but angles having equal measure means that yes, they are congruent. So that's one more step we need to write, that the angle 1 is congruent to angle 3 since their measures were equal, and that is the definition of congruent angles. That's what it means to be congruent. It means that they have equal measure. Okay, so here's our first geometry proof written from scratch, starting with the given, some familiar words that we have there with supplementary, and we can work in some of the same steps that we would see with any algebra proof here as we go along in our geometry proofs as well. Let's take a look at proof number 2. We have BD bisects angle ABC. So ray BD in this picture up here bisects angle ABC. And then we're going to prove that the measure of angle ABC, that's the whole angle up here, would really be 2 times whatever the measure of angle 1 is. Okay, so that's our job or our goal. Understanding, of course, that BD here, this ray, is an angle bisector, so it's cutting the angle in half. So here we go. Let's go ahead and start our proof with our given. Ray BD bisects angle ABC, and that's the given information. Now, going from that given, we need to make another statement about that picture, about this situation. And understanding that word bisects means that you know that angle 1 and angle 2 are in fact congruent to each other. How do you know that? Because you know what the word bisect means. Definition of angle bisector is that you have a ray that creates 2 congruent angles. So we have an angle bisector, therefore we have congruent angles. So we say angle 1 is congruent to angle 2 by definition of angle bisector. Now notice we have a congruent sign in our proof. Eventually we want to get to an equal sign here. So we might as well take care of that right now. We can say the measure of angle 1 equals the measure of angle 2 then. Because the 2 angles were congruent, that means they have equal measure, and that's definition of congruent, or congruent angles in this case. So now that I have the measure of angles in the proof, just like my ending goal here is to have the measure of angles, not just angles, and I have the equal sign like I want, now let's work with what we got here. So the measure of angle 1 plus the measure of angle 2 is where we've left off. Now there's not a whole lot else we can do with that right now, except look back at our picture and see if we can make another statement about this situation. We somehow have to work into our proof this whole ABC angle. So let's think about angle 1 and angle 2 and how they relate to angle ABC, that whole entire angle. Well, you should think back and look on your proof reference sheet, because a commonly used thing when you have angles or multiple angles in a picture is to do angle addition. So we would say the measure of angle 1 plus the measure of angle 2 is in fact equal to the measure of angle ABC, and that's true that if we add how many degrees angle 1 is here plus angle 2 is here, you would get the measure of the whole angle there. That is the angle addition postulate. And that's how we can work in that goal of getting to where we have measure of angle ABC. So we have the measure of angle ABC in our proof. And we also now remember up here, know that angle 1 is equal to angle 2 here in measure. So we can go ahead and substitute. Using the substitution property, we can get to a place where we are only talking about the measure of angle 1s because that's what my goal is in my end result. So I'm going to substitute in the measure of angle 1 where the measure of angle 2 was, because they are equal to each other here. And then I need to go ahead and flip my statement around here by the symmetric property, because notice in my end goal, the measure of angle ABC needed to be here on the left, and my 2 times measure of angle 1 needed to be on the right. So I'm almost there. I have the measure of angle ABC on the left, I have the equal sign, and I have measure of angle 1 plus measure of angle 1. Now that is essentially 2 times the measure of angle 1, right? And we know that because we're essentially simplifying or combining like terms. So this is proof number 2. It's a little bit tougher because we had to add in angle addition postulate, which wasn't so obvious there. Now let's take a look at proof number 3. We're talking about segments here. So in this picture, it says that given R is an midpoint from AM. So R is the midpoint from A to M. And we know MB, this piece right here, is equal to AR. That means their lengths are equal. So we know that these guys are in fact equal. We know that this is the midpoint. We need to show that M is the midpoint from R to B. So let's go through our steps here. The first ones are always that given piece of information. So R is the midpoint of AM, segment AM. and the reason was the given. And then we also had another piece of given where MB is equal in length to AR, and that's a piece of given. So now let's work with our given information. Let's start back up with our first piece. R is the midpoint of AM. So understanding midpoint means that you understand we have some equal lengths in here. And congruent measures. You see on my picture I put the little slashes there? Those are congruent marks, okay? They mark congruency on a diagram. So we can say AR is congruent to RM because we know the definition of a midpoint. So we know that R is in the middle, so he is congruent to AR. Now, if they're congruent, that means they're equal in length. Definition of congruent. Now notice we took away the congruent sign and just changed it to an equals because I need to use this other piece of given information here which had an equal sign in it. MB is equal to AR and AR is equal to RM. So we know that MB has to equal RM using that transitive property. And I put on there, I combined steps 2 and 4 here in that transitive property. Oh, and I hit one more button here. If they're equal in length, then they're also congruent, which is good. So that's the definition of congruency. When they're equal in length, that means they're congruent segments. And we're almost there. It says we need to prove that M is the midpoint of RB. Well, it looks like we kind of already have that part done, right? Looks like M would be congruent, or would be the midpoint of RB, because he has congruent segments on either side there of my M. So by definition of a midpoint, we know that M is in fact the midpoint. We've shown the segments on either side to be congruent. So using things like definition of a midpoint, definition of an angle bisector, definition of supplementary, these vocabulary words become very important in our proofwriting, that we can use those definitions when we need to. All right, I want to thank you for taking good notes on your proofs, and we'll continue to practice proofs in the days to come. Thanks!